So recording in progress for exponential function. Your question number 2 on the worksheet. Let's try to put a good fit on that now. We earlier tried to put just a random guess like this. Like you can plot it here like that, but don't take it below the x-axis because you remember exponential function will not go below the line, the horizontal line. So doing this, but we need an actual real good fit for the exponential function. Let's see how will we do that. First step, go to your Desmos and try to precisely put these dots in Desmos table. How will we do that? We are back in the table, in Desmos here, David. Use the plus sign and put the table here. Can you tell me what is the first dot on the given function? Where does it look like it's 2 and a 0? Looking at the curve here, I was trying to move it a little bit. Okay, plus you. So this you're saying is a 2 and a 0. I will take it. So you're saying x is at 2, the first dot. And when I'm saying the first dot, which dot am I talking about? I'm talking about this dot. So if it's a 2 and a 0, if you think like that, I will bring over here the 2 at x2, y is at 0. Tell me one thing. Can exponential be exactly 0? No. It will approach 0, but it will not be 0 exactly. So let's change the number a little bit. What I will do, I will put there 0.001. I will not force you to put 001. You can do 0.002 as well. Something bigger than 0 to justify the exponential function. What about the second point? Where is the second point on your curve? It's at 4. Let me take it. 4. What do you think is the value for y? Apparently, it looks exactly the same. It also looks like a 0, but let's raise it a little bit. Right, Cameron? We can raise it a little bit, and then we will put there 0.002. Make sense? Okay. Just a guesswork. Just a guesswork. Why am I putting 0, something? There is another hint also. Look at this. Here, just one unit, the change of 1 unit from here up till here, how many points are there? 125. 125. Why? Because this total here is 250. That's the reason that I'm just considering it very close to 0. What should be the next point then? Let's bring in the next point that is on 12, I should say. That does look like a 12, almost. So if I will go to the next point and I will enter over there a 12, what should be the value of y at that point? That looks a little bit higher to me, and I will consider that as a 0.008. Justified? We have another point in the green color which has now appeared over here. But oh my god, where is the 12? My scale doesn't fit the 12. That means I need to fix the scale. How? Again, in the settings, I will go and from -2, I will put it up till 35. Do it with me. Fix the scale over it. I'm fixing the scale to fit in this graph, and for the x-axis, I'm taking it from -2 up till 35. And for the y-axis, I will start that y-axis here from -10, and I will take it up till 1000. 1000. If you will fit and fix the scale exactly in the same manner, you will see now the points plotted over here similarly that I have now with me. Let me take it a little bit down. Now, what's the next point? Let's get back over here. Next point is at around 22.
Yeah.
And what will you claim about the value on the y-axis for 22? Does that look like something 75? I don't mind if you will not put 75. If you're considering it's a 65, you can put 65. I'm thinking it's a 75, so it's really a big scale. So these minor changes will not impact too much. So from here, next point is at 22. And for 22, I considered that as a 75. Next point, which is here, I'm considering that to be at 25. And for 25, it's completely 120, exactly on the curve. So that point, when I'm bringing it in, I will be writing it over there at 25. And at 25, I got it at exactly 125. So let's be quick now. The other one, I'm considering it at 27. And for 27, I will assume it's something like 300, 275. Let's consider that. So I'm considering it at 27. And the value, let's take it as 285. And then the last one, is it not the last one now? Yeah. At 30, what's the value? Talking about this one? 1000. That's why I raised the scale up till 1000. So I will put there as the next value at 30. And for the next value 30, I will put there a 1000. And we got it. That's the plot that we have now in front of us. Everyone has the same thing? Almost the same thing. Okay? Now, if you have something different, definitely your scale should be looking a little bit different. If you have the same scale, you will see this. What's next? What are we doing now? We will try to figure out the equation. Good job. So, to figure out or to fit the equation, we're gonna hit the down arrow key. That will bring us over here, or you can click here, tap here. That's where we will be typing in the equation again in the same manner. But remember, the equation for exponential was different. Equation for exponential was not y equals mx plus b. That was y equals b raised to power x minus c. That's what I will be typing. But with the y, I will put underscore 1. And with the x also, I will put underscore 1. And then we will see if it's a good fit or not. Let's do it. Y underscore 1, right arrow key, shift and then tilde. And then I'm mentioning there b. And then I need to take it to the exponent of b. How can I do that? I can use this combination shift and 6. What can I use? Shift plus the 6. Plus is not the key plus, like it's a combination. Shift and 6 will take it to the exponent. Thank you. B raised to power. Let's put it in parentheses over here. Let's start the parentheses over there. Otherwise, if you will type in something, that will be off the exponent the second term. Here, x underscore 1. You see the plot is already there. Underscore 1. But is it a good fit? No, because it's not touching all the points. It does look like an exponential, but what am I missing yet? Remember from the exponential equation that I gave you? Say it. C. We are missing the C there. So let's bring that in plus a C. What do you think now? Better fit? Not an exact fit, but it's getting closer to the maximum points. Are we good? Yes. See? Yeah, we can definitely close the parentheses also, and then once that's done, how do we put it? Shift and this 0. Shift and 9 will open the parentheses and shift and 0 will close the parentheses. Good? Yes. You don't have 9? Let's just give you one. Before moving further, let me show you a few things here. This is something that I forgot in my earlier video. How will we type in now the equation for this plot? Because the ultimate objective was to find the equation of a function which is representing those dots. Okay? How to write the equation? Now look at this. I'm writing the equation for you. Stay with me. This is the suggested equation that we started with as an exponential equation. And Desmos solved it for you. It gave you the value of the B and the value of C. Let's put it on over there. What I will do, I will write down the equation similarly. The same thing that I have mentioned over here, I will bring this equation over here and writing it y instead of the tilde or approximate or the regression, I will type in there an equality sign. Y equals B. What's the value of B? 1.503 and then raised to power in the exponent. I'm now putting it in the exponent, the rest of the stuff, which is x minus 13.05. Once you did this, we are done. Keep in mind, there is a small margin of error also, which is always mentioned as an E or an error. This is the equation that you will be using here. So this is the equation which is fit, a good fit or the best fit as an exponential for the given function. That's it. I will close now this point. Before closing, the last thing that I missed in the earlier video was this. Here, the determination or the correlation, it should be equal to 1 if it's a strong relationship. If you will see something missing, that will be like, if it's not a good fit or the relation is not really strong, then you will see something like 0.6 or 0.7. If it's exactly 1, that means the variables are exactly related to each other. Correlation and coefficient of determination is used to mention the strength of the relationship. That was the main topic for the day, and we are done.